Looking back on the software development lifecycle, we've seen that projects start with a need. And we've built our interface in this course using controls within Visual Studio. We've coded those controls using Visual Basic, and we've tested and hopefully fixed any errors that we have. But I want to go a little bit deeper into the testing and debugging phase of software development lifecycle as it relates to Visual Basic and Visual Studio, and look at some techniques that we have at our fingertips to help us find those errors and to fix them. So when we're talking about testing and debugging, what we're doing is we're thoroughly testing each project to analyze if any problems exist and to fix them. And we refer to those problems often as bugs, and fixing them we refer to as debugging. And it's kind of fun to talk about the history of that, which goes back to September 9th, 1947 at Harvard University. There was a Mark II computer, similar to what you see here. This is the Mark I. But back in 1947, computers were made up of switches and relays and vacuum tubes and took up lots of space, an entire room. On September 9th, 1947, the Harvard Mark II malfunctioned. And one of the programmer operators at the time was Grace Hopper, who became a rear admiral in the Navy. This is her picture in 1984. But she explored the problem and went in and took a panel off and discovered inside the computer was a moth. And that moth had died and shorted out one of the relays. And here is her logbook from that date of September 9th, 1947. And she actually taped the moth into her logbook. And what she wrote here was the first actual case of a bug being found. That was where that term bug came from in terms of working with computer and computer systems, and removing it became debugging. So we owe that to Rear Admiral Grace Hopper. Now I said we want to thoroughly test our project. We want to test with different types of data and test every possibility in terms of different pathways that our project can take. And we'll talk about those pathways in the next unit when we deal with conditions. We want to make sure that we cover every condition and make sure it works properly. So thoroughly test. Testing and debugging is just as important as writing your code to begin with. If your program doesn't work, then your program has no value. If you deploy a program that has errors in it, you're going to lose a client or lose your job. On July 19th, 2024, the world was hit with a massive computer outage. Affected 8.5 million Microsoft PCs and brought airports to a standstill. Flights were canceled worldwide. Hospitals had to cancel surgeries. Banks couldn't operate. Retail establishments couldn't function, at least not function as well. And this was all due to a bug in a cybersecurity update that was sent out worldwide to Microsoft Windows computers. The bug initiated from a company called CrowdStrike. And notice what Wikipedia says about this incident. The outage disrupted daily life, businesses, and government around the world. Many industries were affected: airlines, airports, banks, hotels, hospitals, manufacturing, stock markets, broadcasting, gas stations, retail stores, and more. As were governmental services such as emergency services and websites. Here in Phoenix, our 911 system went down. The worldwide financial damage has been estimated to be at least $10 billion, all due to an error in the code. Testing and debugging is essential. So we always want to make sure that our projects work consistently and perfectly, so we want to thoroughly test. There are three things we might look for in the testing phase and debugging phases. And one is syntactical errors in our code. Oftentimes this is disruptive. It causes our program to crash. These could be things like we've used the wrong data types, or we misspelled something, or left a comma out somewhere. They're usually very simple mistakes. Maybe we omitted a line of code as we were moving from our algorithm into the code and we forgot a step. Or maybe we made a reference to an outside class and we didn't include that class in our code. We'll see that syntactical errors in our code have red squigglies in them within Visual Studio, which is a nice visual clue that, hey, there's a problem in this statement. We always want to pay attention to those. We'll look at that in a minute. Sometimes though our program works just fine, except we don't get the results we anticipate. These are usually due to logic errors in our algorithm. Now sometimes they are syntactical in nature and that maybe we added something we should have multiplied or vice versa. But somewhere along the lines we made a logic error and we didn't get the results we expected. These are a little bit harder because our program doesn't crash and alert us to the problem, so we need to make sure we test with data and know what we expect versus what we get. And the other thing I'm looking for when I'm testing and debugging is what kind of improvements can I make? When I'm testing a project, I'm looking at the UI, the user interface, and the user experience, the UX, and asking, could this be better? Are the instructions clear? Does the program have a good flow to it? Is it aesthetically pleasing? So I'm looking at not only my code, but also the user interface. How can I improve that? Maybe I'm looking at it going, okay, what features could I add in to make this better? Those are improvements that can be made as we go back through our cycle. Let's go into Visual Studio and look at how we can do some additional debugging. Let's use the project we just created for the baseball stats calc. Up front, I will say the very best way to debug is to learn to read, write, understand, and follow your code. It's a programmer thing. But there are tools that will allow us within Visual Studio to make this a little bit easier. So I'm going to go into the calc batting button here and look at our code. And let's say I made a mistake where in this particular statement, instead of H, I put hits. And notice what happened to my code. I get a red squiggly under hits. If I point to it with my mouse, it says hits is not declared. It may be inaccessible due to its protection level. Now, it's not a protection level thing here. It's just simply that I never declared a variable called hits. That was my error. But that gives me a good clue that, oh, I've got a variable here that's never been declared. And I realize, and I declared up here as H. If I make that hits, that red squiggly goes away. But now I get one here on the H because H was not declared. So I have to make sure I go through and change them all to hits if that's what I wanted. And again, here's another H where I used it that has errors in 2 locations there. So be careful you're chasing errors that you don't create more problems. That does happen. I'm going to go back to these all just being H. We saw the red squiggly there and how that can benefit you. If you didn't notice that, let's say we didn't notice the red squiggly, and sometimes it's just one character, like maybe it was just the H here that had the squiggly. When I go to test it, down here at the bottom, I get the output, and I'm told, oh, there's an error here. And I get a bunch of messages also of some potential issues. Let's take a look at our error. I'm going to scroll this up, and here's my error. Hits is not declared. Same one thing that I saw when I pointed to it. So I can't compile the application if there's syntactical errors. Now if I fix this and I run or test, now my program works fine. And if we look at that output list, I don't have any errors. Now there are some issues here as far as naming rule violations, just pointing some things out. Those are not errors. Those are really more suggestions in keeping with standards. And it says these words must begin with uppercase characters. Methods which include event handlers start with an uppercase letter by tradition. But these were auto-generated based on the name of my controls, which are named with lowercase letters. Therefore, I kind of disagree with this issue. Now sometimes we might declare a variable. I'm just going to declare VB here. And notice I get a little green squiggly. That's not an error per se. That is just simply a notice that I've got a variable here that is unused. I declared it, but I never use it anywhere. I don't need it. So you can pay attention to those, but that will not crash your system. That is not considered an error. Now, if I get rid of that, notice that now I'm getting an error, red squiggly under as. And if I point to that, it's saying keyword is not valid as an identifier because I've got a comma here. It's thinking as is a variable name, and that's a keyword. I can't use it as a variable name. I've got to get rid of that comma. So those are the types of things to look out for in terms of debugging your code before you even run it. pay attention to those squigglies. Now let's suppose that I made a slight error here and I did an asterisk instead of a plus sign. I'm going to multiply that by hit by pitch. And if I run my application, I click count batting, and I realize that my on-base percentage is not correct. Now I didn't get an error, it didn't crash, but if I don't know what data I'm looking for, I won't notice this. So I want to have some test data. So this is a logic error, and that should have been a plus sign instead of a multiplication symbol, the asterisk. Now maybe I didn't know what happened here, and I want to figure out what the problem is. We can do something called setting breakpoints. I can right click on this line, and I can choose to insert a breakpoint. Let's watch what happens when I run this. So I'm going to click count batting, and it stops the application and goes to my code and says, hey, let's take a look at this line. And I can point to each of these different variables and see what the values are. So I can check my values here with that breakpoint. In the debug menu, I have choices where I can step into, step over, and step out. If I step into, it will go line by line through my code, and I can see what the values are. Notice I'm getting the full value here with all the different decimal values, because it's much bigger than what we display. So I can test my values in the code as it's being calculated. So the step into allows us to go through line by line and examine our code. There's also a step over, which will run a method to its completion, or the step out, which goes out of the current method. So we're going to see later on we'll have multiple methods that we're running through. For now, probably the step into is all you really need to worry about. Step into your code, and if you find what the problem is, well, you can just step out. The program continues running, and then you can figure out, okay, this is not the value I should be getting. I need to go in and fix that code. I'm going to run this again. There's one other thing we can do when we are debugging and we're in a breakpoint is we can go to the debug menu and go to Windows, and let's go to Autos. The Autos panel will show us our different variables and what the values are. We can use that to our advantage in figuring out what's gone wrong. The other thing I will sometimes do, I'm going to get rid of my breakpoint here. I'm going to stop my application. We can go to our breakpoint and disable it, and that breakpoint now is no longer there. So now if I run my program, it doesn't break into the code. One thing I will do if I'm trying to figure out what's happening maybe to a value is I will occasionally just simply add in a message box and say I want to see what the value is of hit by pitch. And I see I got a little red squiggly here. I need to fix that. Oops. So I'm going to show the value of hit by pitch to a string, and then my title is simply HBP. So now when I run, I'm getting a message box of here's my value of hit by pitch. We can also print information to a label we put into our interface just for testing purposes, then we delete it later. So I'll use message boxes and printing to labels to look at values in my testing process, as well as that autos. There's also in debug, there are other windows that we can use. But let's set that breakpoint again. I'm going to insert a breakpoint, and I run it. And now my debug, there are other windows that I can use. Locals is another one that will show us our values within the current method or event handler. Again, I'm seeing all the variables and what those values are. And I can test to make sure that maybe I assigned the wrong text box text to a variable. This is one way I can check that. So those are some ways to deal with errors in our code. But again, I think the best way to get really good at debugging is learning to code and to read code and to understand the code. That's what this course is all about. You will get better debugging as you become a better programmer and with more experience. You'll begin to learn what to look for. You'll remember what issues came up that caused problems. So I have to disable my breakpoint and then delete it. That's just a real brief introduction to finding our errors. As I said, the more you do, the better you'll get at this. But it is, as we've seen from the CrowdStrike instance, it can be critical and save millions or billions of dollars. And you think about the lawsuits that might come out of this whole thing and people who have lost their jobs over this. Don't make that mistake. Test thoroughly. Make sure that everything is working correctly. If you just jumped into this video, you can see all the videos from the Programming Practicum playlist by clicking on the image in the lower right. And if you'd like to be alerted to future videos I create, you can click my picture in the top right to subscribe to the channel.